Hello, this is Dr. Oz. In this video, I would like to talk about sensitivity analysis. I will use MandD Chemical Manufacturing Company as an example. So in previous video, we solved this problem and found the best solution to be $800 minimum cost and producing 250 gallons of A and 100 gallons of B. And these are the constraints that we check that there is no violation. So we create a sensitivity report using Excel. So what does this report tell us? Let's go step by step. So as you see here, these are the variables that we have: gallon produce A and gallon produce B. And basically these values right here are the decision variables values that we calculated. If you go back to original model, these are same as your decision variable values. So coefficients here are given as well, $2 and $3. And you can see that we use those $2 and $3 to calculate our objective function, which these values right here. All right. So if I color code them too, these values are same as my coefficients right here. All right. So in exam, I could just give you this report, and I could ask you to calculate the objective function, which is minimize total cost. How would you do that? All right, so I know my decision variables and I know the coefficients. So some product I can use for coefficients, array number 1 and array number 2 is this. So multiply 2 times 250, 500, which is plus 3 times 100, which is 300. So 500 plus 300, it should give me 800. So if I do this, perfect. So this is your objective function value, which we already calculated, but I didn't have to give you the entire model. I could just give you the screenshot. You could calculate the objective function 800, which is exactly the same as 800 right here. All right, so what is reduced cost? So in this case, reduced costs are 0. What it means is that so I could increase this objective coefficient, for example, for A up to $1 and or decrease it by infinite. So still, I would not change anything in my production. So I would still produce 250 products of A, 100 gallons of B. But if I go beyond that, let's say if I increase the profitability of A, so not profitability in this case, if I increase the cost here more than $1, let's say $2, my solution will change, right? So it is easy to test this. So basically what I could do is I could just increase this $2 and increase it by something less than $1, let's say 90 cents, right? I could increase this $2 to, let's say, I don't want to forget about this. So what I'm going to do is I will add here, let's say 90 cents for fun, just to show you. And let's say it cost me now $2.90. Let me just color code this one. I don't want to forget that I changed this value. All right, so now if I solve this problem again, data solver solve, you will see that these values will change. Actually, it didn't change. Let's see what's going on here. Oh, sorry, it should not change because we say that if we increase up to $1, so I increase something less than $1, which is 90 cents. All right. So what if I also now this time if I increase it more than $1? So now instead of, let's say, 90 cents, I increase, let's say, by $1.90. All right. So now the cost is $3.90 instead of $2. So let's solve this problem again. Data solver. Now I do expect my solution to change because I went beyond $1. So if I just click solve and then okay, look at this. Now I don't produce 250 and 100 anymore. I produce less A. Instead of 250, I'm producing 125. Does it make sense? Of course it does, because it's more costly now. So I start producing more B. Why? All the cost of B didn't change, but relatively speaking, it's cheaper than A. And let's take a look at the constraints. Perfect, all the constraints are still satisfied. So that's an important concept here. Without rerunning model over and over again, I can just make these changes. I can make these conclusions. So let me just go back to my original model. $2 and $3. Let's solve it again. Solver and solve. Perfect. So as you see now, still I'm going back to 250 production of A gallons and 100 gallons of B, and that will give me $800. So we covered this part right here. So what happens if I increase the cost of, let's say, B, something really big, right? This means 10 to power 30. Still, my solution should not change. Let's see whether that's the case. So if I increase this by so much, let's say $100, right? So now it costs me crazy, like $103, and see whether it's gonna impact my solution. And according to my calculation, these numbers should not change. So let's go data, solver, solve this model. Okay, and as you see, the production amount did not change. However, it's important to note that my objective value does change because my coefficients are different now. However, my decision variables are exactly the same. Another thing to point out here is that the constraints did not change either because these left-hand side values depend on my decision variable. Except, let me make sure that the cost itself is not here. It's not here, so that's why it did not impact. But if I had another constraint, let's say about budget, then I could observe a left-hand side change. All right, so let's delete this and go back to our original model again, which is $3, and then solve the problem again. So I don't need to solve it again because anyway my problems didn't change. So let's see sensitivity report. We covered all this first part, which is about the decision variables. Let's talk about the constraints. So these are the values, your left-hand side values. Let me just color code them. As you guys know, I like using red. So these are your right-hand side values. If you look at these values, you will see exact same values right here, left-hand side and right-hand side values. Okay. So here, allowable increase and decrease values refer to right-hand side value. What do I mean by that? So I can increase this 350, which is I have to produce at least 350 total products. I could increase this total product requirement up to 125. So let's say from 320 to 450. Then still my solution would stay the same. Sorry, my solution wouldn't stay the same. Of course, it would change because if I require more production, then basically I will start producing more, right? Otherwise, it's not going to be a feasible solution. However, if I do that, every unit increase will increase my objective by $4. So what do I mean by that? So let's do a scenario analysis here. Scenario 1. Increase total production requirement, let's say by 124 units. Okay, so now if I do that, if I do this, right, what I will have in terms of objective function value, I will observe increase of $4 per increase times, since I'm increasing by 124 in this case, which I need to check, which is less than allowable increase. So then my objective function value should increase by $494. So originally this value was $800, So I would expect my solution to go up to $1,296. So let's see whether this is the case, okay? I will increase my right-hand side value by 124 and see what's gonna happen. So I go back to original model and I increase here 124. I wanna make sure that this value, I color coded so that I will change this at the end. I don't wanna forget about it. So now I require my system to produce at least 474 gallons. So if I solve this model, data solver solve, basically I will get 1296, which is what I was expecting to have, right? So that's perfect. So let's go back to our original model again. Delete this. Let's solve the model again. Let's go back to our original model. All right, so now I again have $800. Perfect. So that's what it covers. So within this range, so I could increase it by 125 or decrease it by 50, and still my shadow prices should not change. So this shadow prices will stay the same as long as I increase or decrease my constraint right-hand side values within these limits. If I do go beyond that, basically my shadow price will change, and I need to rerun the model to be able to answer the questions. So let's do another scenario here, scenario number 2. This time I would like to increase time available by, let's say, up to 100 units. So let's go with 99, 95, whatever, 95 hours, something less than 195 hours. All right, if I do that, now I can calculate again my objective function without running the model. So if it was an exam question, you could answer this question easily. So what happens is that I could now, my original objective was 800 plus, now I'm changing my objective function, not objective function, right-hand side value by 95 units increase times, but this has negative shadow price. So this will decrease my objective function, which will help me because it's a minimization problem. Why? Because if I have more time available for me, in this case 95 more hours, will it hurt my objective? Of course not. In worst case, it won't impact at all, but possibly it will impact positively. In this case, positively meaning that decrease my objective, which was my goal, minimization problem. So you can see that I should have $705 instead of $800. So I should have less cost. So let's see whether this is the case. What I'm gonna do here is increase the time available by 95 hours. All right, so if I do this, and if I solve my problem again, data solver solve, you will see that my objective function value decreased to 705 as I expected. Perfect. So let's go back to the original model again, which had 600 hours available for me. And solve it again, data solver solve. All right. Okay. I click cancel. Let's do it again. Perfect. So this is what it tells me. So within this increase and decrease limits for right-hand side values, my shadow price won't change, so I can calculate my objective function. So why does it important? So this is important because to understand what will impact your solution, and based on that, you can make managerial decisions. For example, I know that I'm producing both of these products. Even if I increase or decrease the cost, still I will keep producing same amounts unless I increase the cost by more than $1. So this means that my model is very, very sensitive in increase in objective coefficient of product A, but it's not sensitive at all to production B. So if the cost will go crazy up for production B, so it's still it won't impact my solution. But if the cost increase by a little bit, in this case, dollar, which is 50% or more, and then my solution will change. So it's pretty sensitive. I mean, 50% increase may not be that sensitive, but in comparison to B, it's kind of sensitive. However, opposite is true for decrease. So my problem is very, very sensitive, 33% decrease, which is from 3, decrease it by 1, which is 3 to 2 or more. If I decrease the cost, let's say $1.50 instead of 3, my solution will change. However, if the cost will decrease for A, my solution won't change because it's not sensitive. If I look at again these values right here, my cost will increase every time I increase the production requirement for total production requirement by $4. So that is something to consider. As you see here, it's kind of counterintuitive, right? Here, one production cost of A will increase my cost by $2, and here $3. However, if I ask for one more requirement, it's not 2 or 3, it's even more. My cost will increase by $4. So that's something to think about. So the total production requirement is costing me so much money, $4 per requirement. On the other hand, this is, by the way, binding constraint. What does it mean? Left-hand side value and right-hand side is the same. So the binding constraints are the bottlenecks in the system. We got to be careful about them. So, but this constraint, minimum A requirement constraint, is not binding because it looks like A doesn't cost much. So although I have requirement of 125 only, I produce more than that anyway. So I could increase the right-hand side value up to 125, and which will make my constraint binding or bottleneck. But while I'm increasing up to 125 units requirement, my objective function won't change at all because anyway I'm producing 250. Let's look at the last one, managerial decision here. So this is another binding constraint. I'm using all times that are available for me. If I could buy more time, that could save me $1 every time I increase it by 1. So again, if I can spend 90 cents to increase my time available, let's say to buy new machinery, that's worth it. But because I can save $1 up to 100 though. After 100, of course, the savings will decrease. There will be a diminishing effect. So that's it for today. Today we covered sensitivity analysis, and enjoy business analytics.